Good morning, guys.
Morning.
So yesterday we have seen GDB, introduction to GDB. Now let's learn more commands of GDB. So we have also seen frames when we were doing debugging a segmentation fault. So what is a frame? So a running application, it has a call stack. So this call stack contains information about what all functions have been called. So each item in this stack is a call frame. We call each item in this call stack as a call frame. And the frame contains information which is needed to return to its caller, as well as what all local variables are present in a function. So each item in a stack is a call frame, and each frame contains information needed to return to the caller and the information regarding the local variables of the function. So when you start your program, you only have one frame inside your call stack. That is your main function. Once you call a function from your main function, a new frame is added onto the stack. And if you return from that function, the frame is removed from the stack. So, so and recursive function can generate many frames. So let's see an example. So we have this code. It's very simple code. I have a local variable inside each of the function. Just mute. Whoever is this? Please mute. So I have a very simple code where I'm calling func1 from main and from func2 from func1. And each of the functions are having a local variable. So the first step to use this in GDB is compile it with -g flag and then keep a breakpoint at main and I run the code. First, to find out your call stack, backtrace, BT is backtrace. First, as we said, we will be only having one frame or one item in the call stack, which is the main. Now we'll keep a breakpoint at func1. Now let's continue the execution. Now let's see the backtrace. Now we have two frames inside the call stack. Next, keep a breakpoint at func2 and let's continue our execution. And let's check the backtrace. So now we have three frames inside the call stack. So each time you have a function call, a new frame will be added to the call stack. Once the function is returned, this particular frame will be removed from the call stack. So if I say list, it will only show the list regarding the top of the frame. So I have func2 on the frame 0. So list is only showing the code related to func2. If I want to see the code related to func1, I have to switch the frame. I can switch the frame using frame command. So frame 1 will switch to frame 1. Now if I say list, it will show me the code related to the func1. If I change the frame again to frame 2 as a list, it will show me the code regarding whichever frame it is. Now I can easily verify the value of I variable here. P of I is 10. If I change the frame again to frame 1 as a list, I can check the value of n. I can change the frame back to 0. You can see the value of n. It's still not, this line is still not executed, so n value is garbage. Now let's check the value of n. It's 30. So do single step. Next. Now it's returning this function. Function is getting returned. Let's see the backtrace. Now one of the frame is reduced. Now next backtrace. Now we have only one frame. Next. Next, the program is completed. So this is all what about we have seen about backtrace. What all frames, once a function calls, a new frame is added onto the stack. Once a function is returned, a frame is removed from the stack, and we can move from one frame to another using frame, and then we can check the local variables using print option. Also, you have something known as info frame, which will provide you more information about the frames. So main func1, func2, run. Sorry, we cannot use run here. We have to say continue. We say C. Now we have backtrace of 3 frames. I can say info frame 0. It will give me more information about the frame. So this particular frame is in this particular location of the stack at this location. The instruction pointer is here, and the saved instruction pointer is for that. When it returns, it has to change the instruction pointer to this. And the argument list, it does not have any arguments. The local variables are present at this location, the stack pointer. So using info frame, it will provide you more information about each and every frame. So you can see the instruction pointer here is a RIP here. So using info frame, you can provide more information about each and every frame. So we have seen info frame. Then we have something known as info variables. Info variables will list all the global and static variables. We have seen info. Info is used a lot in GDB. We have seen info functions, which will list all the functions available. We have seen info breakpoints, which will list you all the breakpoint available. We have seen info frame. So info is used a lot. Info variables will list all the global and static variables. Let's see whether we have any in the code which we have. We don't have any global and static variables. Info variables. As we don't have any global, and this is listing the global and local variables for the code which is present in the C library. So as we don't have anything, it is just, let's see, do we have any code which has local variable static. Let's add a static variable to this code. Let's add a global variable, and let's add a static variable. Let's static int I. So let's compile it. Break main, break it line number 22. See, continue. First run, continue. Now we have a breakpoint at line number 22. Backtrace line number 22. So let's call info variables. So it will also list you from it's also listing you the C way codes. So you can just ignore this. Help info variables. Is there any info variables? Source code or see. Okay, let's info variables will list all the variables of each and every file. So you have it's listing almost all the files. Then we have info locals, which will list local variables of a current stack frame. So if I say info locals, I have I variable and loop variable in my code. These are the local variables. So info locals will print the local variables of this particular stack frame. And info args will print arguments of the current stack frame. Info args, we have passed only one argument, which is the name of the executable dot slash whatever. So info args will print. So we can examine the location x slash s argv, right? This is what it is present here. 377 whatever. This is what is present at this particular memory location. I say argv of 0. This is how I have executed this is the path through which I have executed my application. So info args will list the argument values for the current stack frame. So info locals versus info args. Local means local variables. Info args means whatever the arguments you are passing to the function. So you have argc and argv here, whereas for factorial you have n. So info args will give you the arguments. Info registers will list you the register values. So let's see info registers. So it will list you all the registers being used in our code. So you have this all registers used. All the CPU registers of x86, x64 are being listed here. So if you can see info register, if you want a RAX, if you want to list the value of only RAX, you can say info RAX. It will only list you the register which you want. RSP, only that particular register. So info breakpoints we have seen. We have seen info variables. We have seen info frame. Info locals for local variables. Info args for function arguments. Info registers for register values. So when you say info registers, which is shortcut for shortcut is I, register shortcut is R. Info registers, it will give you the first column is the name of the register. The second column is the value of the register in hexadecimal. So this is the value of the register in hexadecimal. The third value is the value of the register in decimal. So there are three columns: name of the register, the value of the register in hexadecimal, the value of the register in decimal. So let's use. How many of you know there is a keyword known as register? There's a keyword known as register in C, right? What this keyword
Yeah,
will do? When, when you assign this keyword register,
it will store the variables in CPU registers.
it will store the variable in CPU register. Correct. So let's see if I add. Let's see where is this value being stored in the which CPU register. We already know we can look info registers to print the values of each and every registers, right? So GDB dot slash example one break main run the program list where I am at line number 9. So info locals will give me the local variables. Info registers will give me the registers. So let's verify the let's print the address of WYE. It is in register RBX. So register variables will not have an address because they are using CPU registers. So this one of the important interview question is, do register variables will have an address? No, they don't have an address because they are not using virtual memory. They are using directly CPU registers. So WYE is stored in RBX register. So initially the value of WYE is 0. Then what we are doing is we are storing the value of, we are asking user to enter a value, and then we are adding, we are first making WYE minus 1. So let's do next, next. Now WYE is minus 1. Not still not minus 1 because this is the next line to be executed. When I do next, now WYE is minus 1. Let's verify register RBX. So RBX is all FFFF, means minus 1. So do next. Now it is asking for us to enter a value. Let's give 15. Do next. Now let's verify the RBX value. It became 15, 14 because we had minus 1 here. Minus 1 plus 15 is 14. Then next. So we have seen how we have seen that register keyword will use one of the CPU registers using GDB in this example. So you have any doubts in this example? We have seen breakpoints. Let's see what is conditional breakpoint. Whenever a breakpoint is enabled, the GDB will stop at the breakpoint. But it is not use. Sometimes it is useful to GD. It is useful if you want to stop at the breakpoint only when once some condition is met. Like if there is a condition, then only I want to stop at this particular breakpoint. Like if I have a for loop uh, and I want to stop at the fifth iteration of the loop, I don't want to stop after each and every iteration. So you can use conditional breakpoints to stop only at a particular condition. So how I can use the conditional breakpoint? First break, position is either line number or function name, and you can use if expression. Or if you have already set a breakpoint, then you can use condition, breakpoint number, and the expression. So this is used when you have not already set a breakpoint. If you already have set a breakpoint, then you have to use condition, breakpoint number, and the same expression. So let's use a sample code. So this is my sample code. I'm having a for loop. I'm calling this function 10 times. And in this function, I'm just incrementing the value of counter. So let's debug it using GDB, gcc source code.c, gdb./source code, a list, break main, list, break at line number 26. So run, continue. It has completed its execution because for loop we should have kept breakpoint at line number 27. Again, let's start it again. List, break line number 27, run, continue, continue. Now you can see it's calling my function 10 times as per the loop. So I can print the value of I. Now continue, print the value of I. It's incrementing, continue, print the value of I. This is no without conditional breakpoints. So each time the breakpoint is executed, my function it is stopping my program and allowing us to see the values. But if I want to execute the breakpoint only at the fifth iteration of my code, so this is my code. I want to stop the breakpoint only when I value becomes 5. So I can say, first I can see info break. There's already a breakpoint at line number 27. So I say condition, breakpoint number is 3 if I equals to 5. So if I equals to 5. So condition, let's see what is the code. There's no need of if here. You can just say I equals to 5. So condition breakpoint number I equals to 5. You can just verify I value is 9. I can set the value of I equals to 0 now. Set I 0. Why? Let's restart it again. Break main, and I will set condition breakpoint at line number 27. Info break condition. When the breakpoint is already set, you have to use condition, breakpoint number, and whatever condition you have, I equals to 5. Now you start your program using run and continue. Now you can see the value should of I should be 5. So the program has only stopped when the value of I became 5. So when I say continue, it will stop and continue execution. It will not stop because I value has changed other than 5. So you can, using conditional breakpoints, you can set a condition to a breakpoint. So any doubts here?
This condition breakpoint is specialized for Linux programming, or it can be done for another IDE like.
It's especially for you can use for any ID like Visual Studio and all. They also provide conditional breakpoints. Uh,
Okay.
GDB is also providing you conditional breakpoints and how we can use. I'm just explaining you.
Okay.
So all the debuggers they provide you conditional breakpoints. Uh,
Okay.
so this was an example where breakpoint was already set, and to keep a condition, then you have to say condition, breakpoint number, and the condition, which condition you want to have the breakpoint to stop. So this is one of the example. The second example is when there is no breakpoint set. Suppose I'm setting the breakpoint for the first time. I can directly set my condition there itself. So GDB source code. So I have this code which is just running for I equals to 0. I'm printing I value. Suppose to put a breakpoint, I say breakpoint line number. Suppose I want to keep a breakpoint at line number 11, and the condition is when I value is 400. So now the condition is the breakpoint will only execute when the I value becomes 400. Stop only if I equals to 400. Just run the code. So you can see it was continuously printing till 399, and now as the I value have become 400, it has stopped execution. So this is how conditional breakpoint works. We have seen two ways. One is before you have set a breakpoint, other is after you have set a breakpoint. There is something known as watch points now. We have seen breakpoints. We have also known as watch points. So what is the difference? Watch points, they are similar to breakpoints, but watch points are set on variables. We have set breakpoints on line number as well as function names. We have not set breakpoints on variables. So watch points are there which are used to set on variables. So whenever these values on the variables are read or written, then the watch point is triggered and the program execution stops. So watch point is used on variables. If you're trying to read a value from a variable, or if you're trying to write a value on a variable, then the watch point will be triggered and the execution will stop. How do I set a watch point? So how do I set a write watch point? You can use the watch command. So we have break command, now we have watch command. The argument to the watch command is the expression which you want to evaluate. So it means whatever the variable you want. So example, watch X. So this is my code. I say list. So break main. Now to keep a watch point on X, it has to be in the scope. So first I can only keep a watch point on the variable until X is in the scope. If I say watch X, it will say no symbol X in current context because this particular code is still not executed. We have not still call run. So let's call run first, and then it will stop at breakpoint. Now we can keep watch X. Now I have a watch point there. So I can again verify what all watch points I have using info break. So info break will also show you the watch points as well as breakpoints. So let's do single step. Next, next, next. So next. So we can see there is nothing modified here. X equals to 20, y equals to 10, and x equals to y. So it should have given us a watch point, but it has not given us a watch point. Let's try it again. Break main, run, watch x, continue. So you can see in single step in single step it will not show you the watch point. Only when you are doing continue operation it will show you, like the old value was 0 and the new value was 10. So in the code we have modified, initially it was 30 and we have modified y value and we have assigned it to 10. So it showed you the new value of 10. I don't know why it is not showing you 30. It should have shown you 30 because we are assigning 30 first. Let's keep a watch point on. So only when you are assigning a values, watch point, when you're writing a values, watch will work. So watch is used whenever you're writing a value. Whenever you're reading a value, watch will not be useful. There is another command known as rwatch. So rwatch is used when you want to read. When someone is reading on a variable, we use rwatch. When someone is writing on a variable, we use watch. When someone is reading on a variable, we use rwatch. If you want to do both read and write, you will be using awatch. So we have three different watch. When we want to check if someone is writing to a variable, if someone is reading to a variable, reading a variable, we will be using rwatch. If we want to do both read and write operation, we will be using awatch. So to disable a watch point, you can use disable command. So you can just use info breakpoints. To disable a watch point, you can say disable to. Now the breakpoint is disabled. To enable a watch point, you can say enable to. So the breakpoint is enabled. Watch point is enabled. So we have seen watch point. Breakpoints are put on functions as well as on line numbers. Watch points are put on variables. We have three different kinds of watch commands. Watch command, awatch, rwatch. Watch is used when you want to look for someone is writing on a variable. Rwatch is used when you want to find out when someone is reading on a variable. Awatch is used when someone is trying to read and write operation. So let's start. So there's a user interface in GDB. We call it as TUI, text user interface. So if you want to see the source code while you are debugging using GDB, you can use by using TUI. So how can I do this? So you have to start your GDB using GDB TUI, or you can say GDB-TUI. So you have this source code, and I say GDB. First, I have to compile it. I say GDB source code. It will not list me the source code. I have to manually say list. But if I want to see the source code, I say GDB TUI. Now it will show me the source code in the top frame. So I can see the source code now and I can perform operations. So I can now keep a breakpoint on main. Now you can see my breakpoint is being placed. So TUI is a very useful way where you can do, we can see what is happening in your code. Now I can keep a breakpoint at line number 19. You can see there is a breakpoint added. What happens if I remove a breakpoint or delete a breakpoint, delete to? So that particular, to refresh the screen, you have to say Control L. So let's try info breakpoints again. So that breakpoint is deleted. Now let's run the code and you can see there is only one breakpoint and that particular breakpoint is here. Now I do a single step using next, 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 next. I say step, it jumps there. Next, 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 next. I say finish, it will come. Finish is not, because it is not used when you have only a single frame. So step, step, finish, it comes out of that particular function. And continue, it has printed. So this is not much accurate, but it is useful. So you have to say Control L to repaint this particular screen. So whenever you have, so let's restart it again. So when you do next, it's printing the value of printf here. So it's printing the value of printf here. So if you want to repaint the screen, you have to say Control L, and this screen will be repainted back. So there are some. It's not so accurate, but it's useful. So next, 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 next. Suppose you have not used GDB TUI. You have just say GDB source code, and you want to see the source code. Now, if you want to enable TUI, you have to say Control AX. No, there's some other option. What is it? You have to say Control XA. I have reversed it. So now, if you want to see the TUI, Control XA. Now you can say break main or run. You have your source code here. Any doubts here? So this is TUI text user interface where you can have you can see your source code. It's similar to your IDE where you can see what is happening, where you are, and you can see the line number where you are. It is highlighting where you are, everything. So this is a text user interface of GDB. So logging. So if you want to log whatever is happening on GDB, you can use logging commands. So by default, GDB will not log anything on the any file. If you want to log anything, you have to say set logging on. This what it does is GDB will say whatever is on the log output to a file called gdb.txt. And you can also disable the logging by saying set logging off. This will disable the logging. If you want to change the name of the log file, you will be using set logging file and the name of the file. So suppose I have this source code. I say gdb./source code. I keep a breakpoint main. I keep a breakpoint at factorial. Now if I want to save everything of these in a log file, I have to manually copy this and I have to right click copy paste. Instead of that, I can say set logging on. Now everything is being copied to a file known as gdb.txt. Now I can run the code. I can do whatever I want. I can print the value of, I can list. So everything what I'm doing is being, oh shit, backtrace, restart, list 1 to 10, restart, list 1 to 10. Somehow I have done something wrong. So I have, what I did is I have executed this command gcc source code.c and I have given the output file name as source code.c. And this has overwritten the source code. This is the common mistake. So my source code has gone. Oh, this is wrong. So I'll just copy my source code back. Instead of saying source code, I did source code.c. Hence it was not showing me the source code. Now I say list, it is showing me the source code. So I say logging on. Now it is copying everything to GDB. I can now break main and I can say run and I can print the value of loop. I can say next and print the value of loop and then I stop my execution. Now I can have, you can see I have a file gdb.txt here, which will be having everything what I have done from. So it has everything from the starting of my session. So it is copying everything to gdb.txt. So logging can be used when you want to save a file, want to save the output of GDB onto a file. Any doubts here?
So Jamal, if gdb.txt file exists, it will overwrite the contents again.
No, it will concatenate, it will append it. You have seen it, we have appended the content, right?
Okay.
So you can give a new file name by using the set logging file command. So it can have a new file there, different file name. So suppose my code is I'm already running my program. So this is my code where I'm just incrementing a variable I, and then I'm sleeping for 1 second. So suppose this is my code is already running. Now if I want to attach GDB to this code, I can do that by using GDB attach command. I can attach to a process using attach command. Attach the process ID. So GDB, I just say GDB. Then I find out uh, the PID of this process. I can run a shell command using inside GDB using shell ps-ef grep for source code. So the source code has PID 22912. I have to say attach 22912. So I need sudo permissions. It's asking for sudo permissions. You need to be root user. So go back to your run as sudo. So the same step again, shell ps-ef grep for source code. So I'm trying to get my PID of the process. I say attach 22912. Unable to open file because the process may be completed until we have. So the process is completed. So let's again run this code. This process is running now. Let's get the PID, new PID. Now the new PID is 22928. 22928. Now we are attached to the process and it has stopped the execution. So you can see I can go to frame 2. I can say list and I'm at line number 10. So now I can check the value of I. So not I can check the value of info locals. I value is 12. So I can now keep breakpoints at line number 10 only if the value of I becomes 40. Now let's continue the code. Now it's continuing for 40 seconds. So after 40 seconds, when the I value becomes 40, then this program will stop and it will give us to examine the contents. So using attach command, you can attach to an existing process which is not running through GDB. Any doubts here? So until it stops, so it has stopped, and I can check the value of I become 40. So I can detach this process using detach command. So now the process is detached, it is running now. After 20 seconds, this will stop. So this is how we can attach to an existing process using attach, PID or detach command. So it is completed. So if I want to see the assembly of my C code in GDB, I can use disassemble command. So I can see the disassemble command, I can see the assembly of my C code. So simple code, I equals to 10, j equals to 20 and all. I compile it. So you should not always use tab, then you will be getting into my situation. VD assembly, I say break main, I say run. Now I say disassemble main. Now you can see it is showing me the assembly version of my main function. Now I can say next, it is executing line by line, and again I can see the disassemble of main to show me the next line. Was the line I plus equals to j, which is being converted into two statements, add ex comma rbp. So using disassemble command, you can see the disassembly, means you can see the assembly of this particular function. Whatever function you give, disassemble will give the assembly of that particular function. So there's a lot we can do from GDB. So we have a lot of commands. Depending upon our use case, we have to use our commands. Most frequently, we'll be using breakpoint, and then we'll be using print command. Then we'll be using info frames. So GDB stack trace. Whenever you have a segmentation fault, you do just GDB the application, and then you can find out which line is causing the segmentation fault. So 13 start command. So we from the starting of our this GDB session, what we were doing is we were doing this GDB source code, then we are keeping a breakpoint main, and then we are calling run. So we were doing two operations. First we were keeping breakpoint main, and then we were calling run. So instead of doing these two operations, you can do in a single operation, which is you can just say start. When you say start, what it does is it will automatically keep a breakpoint at main and stop at the first line. And to start the program as well as it will keep a breakpoint. So start is nothing but break main plus run command. So this we were doing from the beginning, we were just keeping breakpoint main and run. So instead of that, you can just say start. It will perform you the two operations in a single command. So you have something known as command. What you can do is whenever you have a breakpoint, you can run a particular commands. So whenever there is a breakpoint, if you want to run some commands like print a value, you can use command. So how can I do it? So GDB dot slash source code list. Suppose if I want to print, I have kept a breakpoint at line number 14, and I want to print the value of the loop automatically when there is a breakpoint. Command 1. Now you have to type whatever commands you want, print, loop, and finally you say end. Now let's run the code, start the code, run. So it's automatically printing the value of the loop variable. So I'm continuing. Each time a breakpoint is happening, it's automatically running that commands. Whatever commands you have given, it's running that particular commands. So you can see, I no need of typing, always print loop, each time a breakpoint is reached. So using commands, you can run a set of commands, which are GDB commands, whenever a breakpoint is reached. So let's complete our yesterday's quiz where we have stopped it here. We have stopped at 11.
Watch.
Watch command. Whenever there is a segmentation fault, which command we have to type?
Backtrace.
Backtrace.
Backtrace. Breakpoint can be deleted by using which command?
Delete.
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 Step command of GDB. What is the step command performs?
Executes the current line of the program.
And as well as it will stop, right?
Okay.
It will execute the current line as well as it will stop the next statement to be executed. It will display you the next statement which will be
Okay.
executed.
All the above.
Yeah, all the above. Which GDB command can be used to put a breakpoint at the beginning of a program?
B main.
B main. To put a breakpoint in the current line, you just need to say B or break. It will put the breakpoint in the current line. We have not seen. Yeah, we have not seen this example. How to list all the breakpoints?
Info break.
Info break. So that's all about GDB. You have any doubts in GDB session?
What if you want to put a breakpoint in source file, then it can be happen because it is only one source file, right? If we have multiple source file, then wow, how we can put breakpoints on
if you have multiple
particular line.
yeah, I got it. If you have multiple source file, You have to list the name of the file.
Okay.
File.c colon
Okay.
line name or function name. If you have multiple files, you have to provide the file
Okay.
name colon and the name of whatever the function or the line number.
Okay.
Any other doubts?
Ajmal, what about the val grind something if like
Yeah, yeah, we'll see that in our upcoming session. In our upcoming session, just a second, I'm showing my screen. We have seen GDB till here. We have completed. We'll be seeing what are codem files, how to produce codem files, how can we examine these codem files using GDB, and then we'll be looking into Valgrind, the whatever the memory issues which happens in Linux, Valgrind and electric fans. After this, we complete the codem files.
yeah, okay.
So shall we have a session at evening 5:30? Is everyone okay?
Yeah, sure.
5:30. Any problems for anyone? 5:30 p.m. to 6:30 p.m. I think no problems, right? So we'll have one more session, evening 5:30 p.m. Where we'll be doing codem files. Maybe if it is completed, we'll be looking into Valgrind and electric fans.
Yeah, sure.
Okay. So I will be sharing my GDB, all the files and notes. By then you can have a revision. If you have any doubts, you can ask in the evening session.
Yeah, sure.
Chalo, have a nice day.